Welcome to this third tutorial on the NSX platform. My name is Herwig Mannaert, and in this tutorial we are going to look a little bit deeper into the default stack of expanders for the generation of web-based information systems. Now, we have seen that in order to obtain stable software, evolvable software, we need to implement a single functional business entity like an invoice as a set or a collection of various classes. For instance, for the data entity, not just a data transfer object, but also several classes encapsulating the cross-cutting concerns, encapsulating the dependency of the frameworks implementing the cross-cutting concern. And such a set or collection of classes we call an element. For instance, for the entity invoice, an invoice element. We have also seen that for a single cross-cutting concern, like for instance persistency, where there is a dependency on the framework providing the persistency, like GPA provider, that we can have multiple individual classes, multiple concerns or individual classes dealing with the more generic concern persistency and being dependent on a persistency framework like GPA. We have also seen that in the NSX platform, the code generation or expansion platform, that the code generation is based on the expansion or convolution of templates with models. So we have a number of coding templates for an element, and based on the parameters of the model, the name of the functional entity like invoice and its attributes, based on these parameters of the model, those coding templates are instantiated into software classes or artifacts. So for an element, we have a number of coding templates, and for the instantiation of an element, we instantiate a number of coding templates into a number of coding artifacts. We have also seen that while logically these various templates and artifacts belong to an element, when we actually deploy and run a web-based information system, that these various artifacts or classes are distributed over a number of tiers or layers, over a number of tiers of layers of such a web-based information system. Now we're going to look a little bit more deeper into the actual structure of both the artifacts and, of course, the templates or expanders of this default stack for multi-tier web-based information systems, because the artifacts and the expanders are one-on-one related. So we're now going to look a little bit into more how many artifacts slash expanders or templates are there in the various layers. How many are dependent on the various types of technologies or frameworks that provide a cross-cutting concern. Well, globally we can have this overview where we have in the rows the various tiers or layers of the web-based information systems, the view layer, the control layer, logic, data, the root layer, the packaging of the application component, the client layer, the shared layer, and the proxy layer. And in the columns we have the various technological frameworks that provide a cross-cutting concern, usually in a specific layer, like Knockout, Struts, GBA3, GPA, and Maven, or a common technology. Now we add the colors we have been using most of the time, and we see the color for the dependency on a framework in the view layer, in the control layer, the dependency on a technology in the logic layer, in the data layer, and also in the proxy layer. So if we now look at this expander architecture overview, where we see the layers and we see the technologies, we can make a couple of interesting remarks. The first thing we see is that in this upper left corner, but it's not just a corner, it's quite a large area, we have a normalization. We have a normalized matrix. We only have numbers, we only have expanders and an amount of expanders on the diagonal. Now, such a normalization is of course an important thing. It's also why normalized systems theory is called normalized systems theory. A normalization is about architecting one-to-one dependencies, and that's what we want to avoid complexity and ripple effects. Now, the term is widely used. It is in the normalization of a linear transformation. Everyone knows that we strive for a diagonal matrix in order that every output coordinate only depends on the corresponding input coordinate. Related to the spectral theorem, in a spectral analysis of a linear system, it's also a normalization. Every output frequency depends only on the corresponding input frequency, which is reduced complexity and makes it very comfortable, very interesting to analyze. Now, this expander architecture realizes in general, like it's supposed to be for normalized systems, a one-to-one normalization between the functional layers and the implementation technologies, because we have seen in this quite large upper left area, it's a diagonal matrix. So that is already something very interesting. There is indeed a normalization between the functional tiers or layers and the external technology dependencies to a large extent. Of course, we see some entries outside the diagonal as well. We see, for instance, here a couple of entries in the proxy layer based on the remoting technology. The remoting technology, which is actually the EJB technology. Now, the EJB standard and the EJB frameworks or providers combine two different concerns. On the one hand, they take care of the transaction concern, the transactional logic, which is based on the enterprise Java Beans standard. But at the same time, this standard and this framework, it's kind of related, intertwined with the remoting concern, the remoting middleware, to have remote invocations, remote method calls based on remote method invocation of Java. So they're kind of intertwined, and it's very difficult to separate. And then this remoting concern results in artifacts, even in two layers, in the proxy layer. And the proxy layer is there to encapsulate or shield remote invocations from code that will invoke the proxy layer. But it also appears with some artifacts / expanders, because they're one-to-one related, in the shared layer. And the shared layer is there to publicize various interfaces between the layers for the remote invocations and method calls. So then we have at the right side of the overview a couple of other entries outside of the diagonal, and they're kind of the embedded, the dispersed artifacts or expanders. They belong to the Maven build framework and they belong to the common technology. Of course, the common technology, that's quite logical. This is the background technology, which depends only on the background technology, the programming language. And it is logical that this is spread out across the layers, because in every layer we have to use a programming language after all. So it is quite normal that this additional column is not at the diagonal. The Maven framework is also a simple explanation. The Maven framework distributes its project object model files, its POM files, across the structure of the build artifacts. It is so the layers. So we have explained that we need to build libraries or archives on a per layer basis, and so also the Maven POM files need to be distributed or dispersed across the functional layers. Right. Now, if we look again at the overview, now we have talked about the structure, about the normalization, which takes place to a large extent in the upper left area. We have talked about the EJB technology, which for obvious reasons, due to the intertwining of the transaction and the remoting concern, appears in the shared and proxy layer. And we have talked about the common layer and also the Maven technology, the common technology and Maven technology appearing in all the layers. Now let's look a little bit deeper on, then zoom in actually on the various expanders. So for instance, on the expanders of the data layer. And there are here, if we look at it, 10 expanders in the data layer, six which are dependent on JPA, 1 on Maven, and 3 on the common technology. Now, if we give here an overview, we see in the first column the name of the expander, the expandable element, the module it belongs to, the name of the artifacts, of course with kind of a variable placeholder, because if the element has another name, the name of the artifact will be different. And at the right-hand side, we present technology, which is mainly JPA, but also the common or Maven technology. And we still use the colored disks that we use to indicate JPA or persistency dependency. Now, at the first and the last row, we see some XML files located at the level of the component to describe the persistency framework, the POM file of the Maven framework. And so in the middle, we have all these GPA dependent and common expanders, where we can see the expander that expands the CRUD's artifact for the create, retrieve, update, delete, and search operations, the CRUD's internal, the local interfaces, the data expanders, which expands the data artifact. We have been talking about that in the previous tutorial, looked into more detail on that data expander, the finder expander, finder local. And we also see 2 projector expanders. Expanders belong to a certain projection of a data element where we select a number of fields, a number of attributes or relationships, and even some aggregations of attributes of relationships. And they kind of have their own expansion module with a number of expanders. Okay, so every one of these expanders expands an artifact, and the full name, of course, consists partly of the name identifying the actual type of artifact in the element structure, and part of the name reflects the name of the functional entity. So for instance, if we have a invoice data element, the data element placeholder is replaced by invoice. And if we have within that invoice data element specific projections, for instance here, then we have also the name of the projection, for instance, a details projection or a dataref projection reflected in the name of the generated artifact, the projector class. Now, looking still a little bit deeper, zooming in even a little bit deeper to 2 individual expanders, let's take the example which is the most peculiar. Let's take the most peculiar expanders, there we learn the most. So the projector expander and the dataref projector expander seem a bit redundant, as the dataref is basically just another projection with only the name and the identification and the package and not much other attributes. So it's quite similar, but it's another expander. And if we look into the details of the declaration of these various expanders. And we have seen in the previous tutorials that expanders are declared or defined or specified in an XML file or document. Then we see that the projector expander and the data ref projector expander look extremely similar. Of course, they have the same package, the same layer, the same technology, same programming language. They belong to the data projection, which is a sub-element of the data element. We see how the name is constructed. But of course, they're quite similar. We have, for the data ref projection, we have to use the data ref projector. And for the other projections, we have to use the projector. And so actually they have an is applicable condition, which is mutually exclusive. So either it is the data ref projection, and then the data ref projector expander will be used and will automatically generate the data ref projection artifact, or it is not a data ref projection, it's an other projection, and then the data ref projector will not be used, but the projector expander will be used and will generate an artifact with a name in accordance with the actual projection. So we have two expanders here doing a little bit the same, but a bit different, and they are mutual exclusive. We come back to our general overview of the expander architecture, where we chart the layers and the technology. And let's take a second look now into more detail. Let's zoom in on a second set of expanders and artifacts that are generated by those expanders. Let's look at the EGB3 logic expanders, which are 8 of them. If we look at the overview here, we see once again expanders, the element, the expansion module, they belong to the artifact name, the name of the artifact that will be generated, and the technology, which is here EGB3, and we use the standard colored disk to symbolize the dependency. Now we see that we have a number of EGB3 dependent expanders and therefore artifacts to be generated for the data element, a local interface, an agent local interface, bean anchor local interface, the actual bean expander, the transactional encapsulation of the CRUDs, the create, retrieve, update, delete, and search operations of this data element. We also have the transactional encapsulation, the bean expander for a task element. And we have for flow and a service element an engine bean expander, which is actually the transactional bean that performs the engine to drive the flow. Now, we will come back to that immediately, but the service element is the engine bean of the service element. It's kind of a variant of the flow element. It's basically a flow, but instead of executing sequentially the various tasks as a state machine, it is in a repetitive way executing the same task all over again and returning every time to the same state. So it's kind of a variation on the flow element, and it's purely for implementation reasons that it was brought together in another module, a service element next to the flow element. Now, once again, part of the name of the artifact that is generated reflects basically the actual artifact in the element structure, like local agent, bean, engine bean, etc. And part of the artifact reflects the functional entity for which this element is being instantiated. So if we have, for instance, a data element called invoice, like we have in all our examples, then this data element name is actually instantiated as an invoice. Now suppose we have a task element sender, like we have been using in our artifact. We would have a sender bean, And for the flow or the service element, and that's kind of a variation of the flow element, then we could have, for a state machine or a flow on the invoices, we could have a flow element, for instance, called invoicing, and then the artifact would be called invoicing engine bean. Just like in the previous zoom, where we zoomed in on the data layer, we zoom a little bit more in on the expanders which seem the most peculiar. And so, of course, which seem the most peculiar are the two engine bean expanders belonging to the flow element and the variation service element. And if we look into more detail, we see here for the flow element, the engine bean expander, the package name, the layer, the technology, the source type. We see the way the artifact is named, the path that it is constructed, etc. And we can see the same thing for the engine bean expander in the service element. But of course, it was a variation, and it was just for implementation reasons in the original stack of the 181 expanders that it was a separate element or module. And actually, in the meantime, it has been absorbed in the flow element, and it has become just an option is service. So if the flow element .get option is service is defined, then the engine bean expander of the flow element will generate an engine bean, which is completely similar to the engine bean that the service element engine bean expander used to generate. So this just to address some of the more peculiar things, because all the rest is really, really straightforward. It is straightforward. We have for every layer a number of combinations of expanders and artifacts to be generated that are dependent on a certain technology, that are declared or defined in an XML document, and then we have the whole mechanism of the XML mapping and of the string templates and of the instantiation of these templates. So, of course, like always, if there are any more questions, you can always contact me. Thank you.